MCT4C, we're going to do days 9 and 10 together so you can have a little break for tomorrow night. But we're going to be doing factoring. And this is review for you. And we're going to do it pretty fast. And your skills should be pretty strong from what I've seen in class recently. We always start by looking for a greatest common factor. If I can be lazy, always, it will make our life easier. So for the first one, we look at numbers, at A's, at B's, and see if we can find a common factor for all the parts in each term. So they don't both have a number other than 1. They both have A's. So I have to go with an A to the power of 1 so that it goes into both terms. And a B to the power of 1 would be my greatest common factor. Throw up a set of brackets. And my brain is thinking, undoing distributive law. What do I multiply AB by to get what I started with? For the first term, I have AB outside. I need another A there to end up with A squared B plus. I have AB on the outside of the bracket. I need a 3. I already have an A, and I need B cubed to get what I started with. I have common factored. For the second one, there is a greatest common factor of 5. There aren't x's in all 3 terms. So we would throw up a set of brackets and determine what I would multiply 5 by to get the 3 terms that I started with. 5 times 5x cubed plus 3x squared plus 2. Greatest common factored. For this one, it's a strange little example, but I have 2 terms, one here and one here. And both of them have a common factor of x minus 2. X minus 2 times what for the first one? Well, times 2x. For the second term, it's times negative, invisible, 1. So if I did FOIL on that, I would get the same as if I did distributive law on the left side. So I have greatest common factored it. The next slide is factoring by grouping, and there's a means to an end for this. It's so we can use these skills when we're factoring by decomposition. These two have 4 terms, and I'm going to factor by looking at the first 2 and then ignoring them and looking at the second 2. So the first 2, 2b squared minus 3b, has a greatest common factor of b. I put up a set of brackets. B times what gives me those 2 terms? Well, 2b subtract 3. Then I look at the second pair of terms and look for a greatest common factor for those, which would be 2c. Sorry, I almost missed that too. 2c times what would give me what I have for the second pair? I need a 2 and a b. And for my last term of minus 6c, I need a minus 3. Interesting. My 2 brackets are identical. So I can put that information together and write my common bracket times the leftovers, b plus 2c. And that is fully factored. For the second example, again, I have 4 terms that I am going to look at the first 2, ignore them, and look at the last 2. For the first 2, I have a greatest common factor of x squared. X squared times x plus 1 gives me those first 2 terms. For the last 2 terms, my greatest common factor is 3, and it would be 3 times in brackets x plus 1. Now I can put that information together and take out the common factor of x plus 1 and write the leftovers in the second bracket. Moving right along here. Simple trinomials. My thought process would be, is there a greatest common factor? And for all 4, the first 4 examples, there isn't a greatest common factor other than 1. The last one does have a greatest common factor, so we'll deal with that one when we get there. Once I see that it is a simple trinomial, and by simple I mean there is an invisible 1 at the beginning in front of the x squared. If it's a number larger than 1, then we have to use a different strategy. But for factoring a simple trinomial, I need to throw up 2 sets of brackets, and I am basically undoing FOIL, or going in the opposite direction. So when I fill in my 2 brackets, I can do a quick mental FOIL on them to make sure I get what I started with. So to undo or factor x squared minus 7x minus 8, I need an x at the beginning of both brackets. I need 2 numbers at the back half of the brackets, and those 2 numbers need to multiply to negative 8. So when I do FOIL on these brackets, my lasts will multiply to negative 8. For outside inside, when I do that with my 2 brackets, my outside and inside would need to add to negative 7. So the 2 numbers I need in the brackets multiply to negative 8 and add to minus 7. Minus 8 and 1 work. So minus 8 and positive 1. We're going to do a quick FOIL on that just to check that we did it right. So FOIL would be firsts, x times x, x squared. Outside would be the x times the 1. Outside would give you an x. Inside would be these 2 guys, minus 8x. And lasts would be the negative 8 and the positive 1, negative 8. If I were to tidy that up, I would get x squared minus 7x minus 8. Bingo, it matched. For the second one, same strategy. There's not a greatest common factor other than 1. So it's a simple trinomial. I can factor it by throwing up 2 sets of brackets. I'm undoing FOIL on this trinomial. So I need an x at the beginning of both brackets. So my first will multiply to x squared. The 2 numbers that I put into the brackets will multiply to minus 18 and add to positive 3. What multiplies to 18? If you're kind of stuck for numbers, that's the good starting place. What multiplies to 18? 1 times 18, 2 times 9, 3 times 6, and I think we got them all. One of those pairs, if I have a mix of positive and negative, can get me to the number 3. It would be that pair right there. If I'm multiplying to a negative, I need a positive and a negative. And if I want my 2 numbers to add to a positive, the larger of these 2 will be the positive. 6, 3. Done. On to the next. Factoring x squared minus 11x plus 18. It's a simple trinomial. I throw up 2 brackets with an x at the beginning of both. I am multiplying to 18. I like that number. Adding to negative 11. If I am multiplying to a positive, the signs in my brackets have to either be positive and positive or negative and negative. Which should it be if I'm adding to negative 11? Well, they're going to have to both be negative numbers. So now I have to determine what those numbers are. What multiplies to 18? Well, we happen to have a list already, and one of those pairs that have the same sign will add to 11, the 2 and the 9. Check. Do your numbers multiply to positive 18? Yes. And add to negative 11. Fourth, factoring x squared plus 5x plus 4. 2 sets of brackets. X and x multiplies to 4, adds to 5. Multiplying to 4, you could do 2 and 2, but that doesn't add to 5. Or 4 and 1 will add to 5. We have factored simple trinomials. The fifth one, we should look always for a greatest common factor first, and this one has one. 4 divides into all 3 terms. So I'm going to factor that 4 out first. 4 times s squared minus 12s plus 36. So we have factored out the 4. We're going to continue Inside the brackets is a simple trinomial, so I will factor it by throwing up two sets of brackets. At the beginning of both brackets is an s. I want two numbers that multiply to 36 and add to negative 12. 6 and 6 will work if I have both of them negative. And I am done. Next page. And for some more fun, trinomials in the form ax squared plus bx plus c. This is the one that gives us a bit of a headache. Thought process is there a greatest common factor? Because that might simplify things right there. Number 6 does not have a greatest common factor for 3x squared, 7x, and 2 other than the number 1. So no, we cannot factor that other than doing decomposition. So we call the process of factoring these difficult ones decomposition. Sounds lovely. Here we go. My goal is to decompose this middle term of 7x into two parts so that I can factor by grouping. So I am going to decompose this into 3x squared plus 6x plus 1x plus 2. Notice that this is really the same as this. It's just written a little bit differently. Now I'm going to factor by grouping, where I look at the first two terms by themselves, find a greatest common factor for them, and then I'll do the last two terms in a moment. Let's look at these two. 3x squared plus 6x, my greatest common factor would be 3x. In the brackets, I have an x plus 2. Done. Look at the last two. The only common factor for those two is a 1, so I'm going to write it down and throw up a set of brackets. 1 times x plus 2 is x plus 2. Final answer is the common bracket, x plus 2, times the leftovers, 3x plus 1. It's not officially the leftovers. What we have is a greatest common factor of x plus 2, and we're writing down what we multiply it by. But if you write down leftovers, it'll help you remember. But how did I decide to split it into 6x and 1x and not something different? Well, my strategy is, and I'm going to do the next example, I'm going to decompose that 8x into two parts so that my two parts will add to 8. Of course, I have to add to 8x. I can't change the question. But if those two parts also multiply to, watch the little red arrow here, negative 20, I got that by multiplying the outsides, it will work every time. So I'm going to rewrite my question as, oh, I haven't chosen my two numbers yet, sorry. Multiply to negative 20 and add to 8. Well, what multiplies to 20? 1 times 20, 2 times 10, 4 times 5. My numbers are going to be 2 and 10. And if I make the 2 negative, my numbers multiply to negative 20 and add to positive 8. So I'm going to rewrite, now that I've found my magic numbers, I'm going to rewrite my question as 5x squared plus 10x minus 2x. And the order of these two doesn't matter. You choose. Subtract 4. Now that I have this as a 4 term, there we are, we're going to factor by grouping. First two, and then second two. So looking at the first two, I have a greatest common factor of 5x. In the brackets, I would write x plus 2, do a quick mental distributive law, checking that this and this would give you these two terms above. The second two terms have a greatest common factor of negative 2, x plus 2. Now I was also a little bit careful there. I chose to have a greatest common factor of -2 because I knew that I wanted these two brackets to look identical. So I forced it a little bit because I want to write my final answer as the common bracket of x plus 2 and the leftovers 5x minus 2. Final answer. The last one, 45x squared plus x minus 2 is kind of hideous. We're going to decompose that middle term of 1x into two parts so that my two parts add to 1 and multiply to, put those two together, minus 90. My two numbers will be 10 and 9, and I will make the 10 positive and the 9 negative. Do a quick mental check. Do they multiply to -90 and add to 1? Yes, they do. So I am going to rewrite that problem, decomposing the middle term. All right, I'm going to replace that 1x with a 10x and a minus 9x. The order does not matter. Let's do the minus 9 first. Plus 10x. So I haven't changed the question. I just make it look different. I do the first two, and then I'm going to do the second two. First two, greatest common factor for those two is a 9x times, for the first term, I need a 5 and another x. The second term is the very same, so I would put subtract 1 to make sure I don't lose him. For the second two terms, my greatest common factor would be 2. In the brackets, well, we know what we're aiming for. 5x, check, and minus 1, check. So final answer would be that common factor of 5x minus 1 times the leftovers 9x plus 2. Difference of squares. If you have a good memory, difference of squares is your friend. It's easily recognizable. It's a very specific type of trinomial where you have an invisible zero middle term. We don't have to write that, of course. So it would be anything that looks like a square, subtract another square. And 16 is 4 squared. It's beautiful. So the first one is x squared minus 9. Both of those are beautiful squares with a subtract in between. It's a difference of squares. Difference of squares can be factored so beautifully. Two sets of brackets, an x at the beginning of both, just like our strategy from before. And at the back half of both brackets would be a 3, the square root of 9. One of the brackets is positive and one of the brackets is negative. So that when you do first, outside, inside, last, your outside inside would be minus 3x and positive 3x, giving you 0x. Beautiful. The second one is a difference of squares. The giveaway is two things with a minus sign. That means we can throw up two sets of brackets. They're going to look identical, but one is going to have a positive and one is going to have a negative sign. At the beginning of the brackets would be 4x, 4x. I'm thinking square roots of 16 and of x squared. The back half of the brackets would be 5 and 5. The third one looks like a difference of squares, but it's not because it doesn't have a subtract sign. So we have to use other strategies to factor this thing. We would look for a greatest common factor. There isn't one other than 1. Or we can factor as a simple trinomial, and this one won't work so nicely. This one is not factorable. It is what it is. The last two are kind of tricky ones. See if you're awake. That one's done. 1/4 a to the 4th minus 1/16 b squared. The giveaway is that we have two things with a minus sign. It is a difference of squares. So we have two brackets that will look identical, except one will have a positive and one will have a negative. At the front half of the brackets, we want something that gives us, let's do the numbers first, a quarter. So I'm going to put a half and a half in each bracket. I want a to the fourth, and I want them to be identical. So I'm going to put a squared, a squared. There, I have my first terms figured out. The back half of the brackets will be something that multiplies to 1/16. That would be a quarter and a quarter. And the back half of the brackets would give us b squared, so b and b. That's ugly. That's just reminding you about your rules of fractions. And the last one, we should look for a greatest common factor always first. And this one has a greatest common factor of p. In the brackets, so I'm thinking distributive law, I would need p squared for the first term and a 16, subtract 16 for the second term. So that is taking out my greatest common factor. But I can continue with what's in the brackets and factor further. So I would rewrite my p, factor p squared minus 16 as a difference of squares. So two sets of brackets with p at the beginning of both. They will look identical, but one will have a plus and one will have a minus, and 4 goes at the back half of each bracket. We are done factoring difference of squares. I've stolen the following question right out of your textbook, but I thought we'd do this one here together. The volume of a box is modeled by the polynomial expression x cubed plus 3x squared plus 2x, with the height of the box being the shortest dimension. Determine the expressions for the length, the width, and the height of the box. So we have an expression for volume in terms of the dimension x equals x cubed plus 3x squared plus 2x. We know that volume is length times width times height. So if we can take that expression and write it so that it looks like a multiplication, it might be obvious to us what the length, the width, and the height are. When you are writing something as a multiplication, you are factoring. So right now I have an expression that has addition and so on. So I can write it as a multiplication if I factor. So we look for a greatest common factor first. There is one. Let me write that down here. Greatest common factor. Don't forget. There is one. It is x. We would be left with, if I factor that out, x squared plus 3x plus 2. I'm going to see if I can go any further. That looks like a simple trinomial, which means I would throw up two sets of brackets with an x at the beginning of both. I need two numbers that multiply to 2 and add to 3. Isn't it lovely? The numbers are so small. There we are. We have written our volume as a multiplication. So we have something times something times something. They told us that the height was the smallest dimension. So this would be our height. The next largest dimension would be the x plus 1. So I'm assuming that would be the width. And the length is usually your longest. Kind of makes sense. X plus 2. So we have found expressions for the length, the width, and the height. So the height is represented by, of course you're going to give me nice form and always give me nice sentences. X, the width by x plus 1, and the length x plus 2. I have some handouts for you, and out of your textbook 103 to 104 and 106, we have lots of practicing to do. I know it's review, but practice makes perfect.